we will discuss photoelectric effect. In 1887, Heinrich Hertz performed a very important experiment. So what was the experiment? When some metals like cesium, potassium are exposed to strong beam of radiation, electrons are ejected. Later on, this phenomena was explained by Albert Einstein in 1905. What he concluded? The radiation with frequency, that is, when the radiation with frequency greater than certain minimum frequency, called the threshold frequency, strike the metal surface, electrons are ejected from the metal surface. These electrons are called photoelectrons, and the effect and the phenomenon is called photoelectric effect. The minimum frequency which a radiation must possess is known as threshold frequency. It is denoted by nu zero. The apparatus used to study photoelectric effect consists of an evacuated tube fitted with a metal sheet which acts as cathode and a detector which acts as anode. These two are connected to the external circuit through an ammeter. When a strong radiation having frequency more than the threshold frequency strikes the metal sheet, electrons are ejected, known as photoelectrons, and were detected by the detector. By observing the current flowing, the kinetic energy of these electrons can be determined. Three important factors were observed about this photoelectric effect. What is the first fact? The electrons are ejected only and only if the radiation striking the metal surface has a frequency greater than threshold frequency. The minimum energy above which electrons are ejected is known as work function, denoted by W0. This is h nu 0. So W0 is equal to h nu 0, where h here is Planck's constant. So this is W0. The difference in energy is transferred if the radiation has the energy more than the work function. The difference in energy is transferred as kinetic energy of the photoelectron. As per the principle of conservation of energy, h nu minus h nu 0 is equal to 1 by 2 MeV square. So this is kinetic energy of the photoelectron, where me is the mass of the photoelectron, so v is the velocity of the photoelectron. So this is kinetic energy. The difference energy is equal to kinetic energy of the photoelectron. So we can write h nu is equal to h nu 0 is equal to 1 by 2 plus 1 by 2 MeV square. So or we can write like this: h nu is equal to W0 plus 1 by 2 MeV square. The second fact is that the velocity, hence kinetic energy, of the photoelectron is proportional to frequency of the radiation and independent of its intensity. That means if we increase the frequency of the radiation, the velocity, hence kinetic energy of the photoelectron will increase. ऐसे में कह सकते हैं कि velocity of the photoelectron जो photoelectron की velocity है या kinetic energy है, that depends upon the frequency of the radiation. If the frequency of the radiation increases, velocity or kinetic energy accordingly increase. So the third fact, number of electrons ejected. Number of electrons ejected. यानी number of electrons ejected, कितने electrons eject होते हैं? It depends upon the intensity of the radiation of a particular frequency. So जितना radiation की intensity ज़्यादा होगी उतनी ज़्यादा electrons eject हो जाएंगे. So number of electrons ejected is proportional to the intensity of the incident radiation on the metal surface. So one more point is stopping potential. What is stopping potential? This is the potential applied corresponding to nu zero. Corresponding to nu zero. The potential applied corresponding to nu zero is known as stopping potential. What it means? That means below this frequency, no current flows. The current flow will be zero. So now we'll conclude the topic photoelectric effect. What is photoelectric effect? When radiation with frequency greater than certain minimum frequency called threshold frequency strikes the metal surface, electrons are ejected from the metal surface. This effect is called photoelectric effect, and the ejected electrons are called photoelectrons. Thank you.